Brady says it keeps failing on me, but I feel like it's okay. I will take a look at the one I just posted yesterday. Did it again? All right, I'll take a look and see here. It shouldn't be doing that. Check. Yeah, it should be working. Okay, anyway, what? Yeah. Okay, so here we go. All right, so again, this paper right here is not what the quiz will look like, but there's important questions on here, okay, on the front and the back. This is what tomorrow's quiz will look like, okay? This and this, okay? So keep that in mind, all right? So, all right, let's start here.
I need to get some preface stuff.
Okay, well, we're going to work on this here today in class.
Please show me.
All right, we're going to do it. You got it. Mm-hmm. All right, your wish is my command. So here we go. We got a word bank here. Number 1, standard form of a quadratic function is y equals ax squared plus bx plus c. Cross it out. Okay. The shape of a quadratic equation is called a parabola. I hope not. Okay. Number 3, this thing is called not the x-intercept, axis of symmetry. That's right. Okay, axis of symmetry. This point right here is called the vertex. Sorry. Axis symmetry, gone. Vertex, gone. Okay. Alrighty. So far, so good. Number 5. When the vertex is the highest point on the graph, we call that a maximum. When the vertex is the lowest point on the graph, we call that a minimum. Okay, minimum, maximum. We have 2 options left. It's either zeros, roots, or x-intercepts. Okay. Ooh, interesting. Yeah, you can kind of like interchange both of these, actually. Okay? Because x-intercepts, zeros, and roots are synonymous. So your choice, okay? Zeros and roots and x-intercepts, they all mean the same thing. It's where the graph crosses the x-axis. So you can put whichever one you want there in 7 and 8, your choice. So I'm going to put zeros, roots for this first one. I'll put x-intercepts here. But you could really do it either way. It's the same thing. Okay, they mean the same thing. Okay? All right, so let's look at this one right here. The directions ask us to determine whether the quadratic functions have 2 real roots, 1 real root, or no real roots. So in other words, 2 real solutions, 1 real solution, or no real solutions. And if possible, list the zeros of the function. Now, it's a little bit hard to see here, so I'm going to highlight this with my pen. Actually, I'm going to use my felt tip pen. Okay, so I'm going to re-highlight the x and y axis there just so we can see that a little easier. I'll do it for this one right here as well. Because it's not so they look like just regular old grid lines, which is harder to, identify what's important here and what's not. Okay. So, looking right here at this graph, how many zeros or roots or x-intercepts do we have here? 1, right? It crosses the x-axis just at this one, like kind of kisses it and goes right back up. So we're going to put a 1 here. 1 root or 1 0 or 1 x-intercept, okay? And what is the 0? 3, 0, right? Or 3. You can just say 3 or 3 0 is fine too. Question? What is a root? It means the same thing as an x-intercept. It means the same thing as a 0. So it's where the graph crosses the x-axis, or where the graph touches the x-axis. So x-intercepts, roots, and zeros all mean where the graph touches the x-axis or crosses the x-axis. Okay? How many times here? How many roots here? 0. Very good. And so, can I write anything here? No. So just put like a little dash. You can put n/a if you want to for not applicable. Does not apply. Not applicable. Not able to be applied. Applicable, right? Able to be applied. Applicable. Applicable. Okay, you sound fancy. That's all it means.
2.
Okay, 2 roots. That's right. And can we tell what they are?
0, 0, I think.
Yeah, 0, 0 is one of them at the origin.
And -2, 0.
Yeah, very good. -2, 0. Okay, easy peasy, right?
Yeah.
All right. Turn the page. Okay, got another graph here. Let's identify some pieces of information. Now this graph, they should have arrows on the end of those. So I'm going to put a couple arrows at the end. Okay. Let me skip axis of symmetry for right now. Let me skip down to vertex. What's the vertex here?
3, -2.
3, -2. Exactly right. So if my vertex is 3, -2, my axis of symmetry is going to be what? 3. And don't just say 3 though, right? We got to say x equals 3. And I that's okay if you said 3, but remember it's an equation of a line, right? So it's actually x equals 3.
How many zeros? 2.
How many zeros are there? Yeah, I count 1, 2, right? Where the graph crosses. Bless you.
2, 0.
Okay. And yeah, where are those zeros? What's their location? So 2, 0. Careful, 2, 0. X coordinate first. And then 4, 0. Okay. What's the domain? What's the domain for every parabola? Negative infinity to infinity. Okay. Always, always, always. Okay. What's the range here? Bottom to top. What's the bottommost y coordinate? -2. Topmost y coordinate, infinity. Goes to infinity. Okay. Questions on any of that so far? Making some sense here. I just want to make sure this is like we're just like lightning review here. Lightning. Fast. Okay. Lightning fast. Quadratic review. Any questions thus far? Okay. Stop me if you heard this one before. Yeah. So range describes the y's, and it goes bottom to top. Got it? Next, graph the following quadratic functions by using critical values and or factoring. So critical values, that's another word that we haven't really used in this class, but it's like the zeros, the max and min, stuff like that too, and or factoring. Okay, you need 3 points to graph. We're going to use 5, but really 3 if you count symmetry and stuff like that. And you don't necessarily need all the information listed. Okay, so remember some things, right? Yeah. Okay. Well, okay. We'll skip all that stuff. You can use this if you want to, but I like using this right here. So, what form are we in here? What form is this? Do you guys remember? Standard form. Okay. So, to find the vertex in standard form, we have 2 options. Option 1, you can use your graphing calculator. Right? Type this in your graphing calculator and then find either the maximum or minimum depending on where the vertex is, depending on how it's going to be. In this case, since our A is going to be what here? What's our A value? Positive 1. So that means it's going to be concave up like a cup or concave down like a frown. Up, right? Cup, like the cup, right? And since it's going to be concave up, our vertex is going to be the what? Maximum or minimum? Minimum. So you can then find the vertex of this if you graph it and then use your minimum command in your graphing calculator. Okay, that's one option. The other option is when you're in standard form is to use x equals negative b over 2a. Right? That's the other option you could do here to actually calculate it. Okay. What is the b value in this? Negative 2. So it's going to be negative parentheses negative 2. Right? You have a negative in front of the b. b is negative 2, so it's negative 2 there. Okay, you have to, yes, write 2 negatives. Okay, over 2 times, and what's our a value in this problem again? 1. Okay, and so we'll just simplify. What's negative 2? What does that simplify to be? 2. 2 times 1, 2. What's 2 divided by 2? 1. Aha, so we have our x coordinate there. So x equals 1. That's our axis of symmetry. I could put that right down here. Bada bing. Okay, we got that one. How do I find the matching y coordinate? What do we do with that x value? Plug it in, plug it in. That's right. So 1 squared minus 2 times 1 minus 3. Okay, so I took that x value of 1. I'm just plugging it back in here to find the matching y value. And simplify. 1 squared is 1. Minus 2 times 1 is 2. Minus 3. And so yeah, 1 minus 2 is negative 1. Minus 3 is negative 4. So yep, we get the point 1, negative 4 for the vertex, which we'll put right there for the vertex and the axis symmetry. Okay, I'm going to go over here and plot that point then. 1, negative 4. Oh my goodness. This kind of hurts my eyes to look at a little bit here. Let's see. So I'm going to highlight the y-axis here with my felt pen. The x-axis looks pretty good to me. Yeah, I know, right? That's kind of, let me see. Does that help if I zoom in some? Move over 1, down 4. 1, 2, 3, 4, point. Okay. How can I get more points? What do I need to use? Use a calculator. What can I draw, though? A table. Thank you. Table. Draw a table. Put the vertex in the center of the table. Give yourself 2 points above. Give yourself 2 points below. Okay? We'll do 0, negative 1. We'll do 2, 3. And now I'm just going to go to the table on my graphing calculator. Okay? If you didn't want to use your graphing calculator, how could you find these matching y values? What would you do with each one of these x values? What would you do? What? Plug them in. Yeah, it's going to be some work, but you can do it. I'm going to type it in. Go to my table. It is. Yeah, negative 1, 0. Negative 3. 0, negative 3. 2, negative 3. And then 3, 0, right? Okay. So, negative 1, 0. Right there. 0, negative 3. 1, 2, 3. 1, negative 4. 2, negative 3. You can use that symmetry. Right in here, symmetry again. 1, 2 away, 1, 2 away, right there. Okay, there's the graph. Now, just because I've got my graphing calculator right here, so I'm just going to plot a few more points because I got some more space there I can fill in. So I'm going to do some more points here. So, for example, I have like negative 2, 1, 2, 3, 4, 5. I can plot that point. And again, I can use symmetry to put that point right there, okay, which is 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Yep. Question?
If you just did those points,
it would be okay. Okay, but I like to fill in the rest of the graph, so I'm going to do that. You don't have to, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow, it does go up to 12, and I can do 12. So 5, 12 is going to be right there, and then there's going to be that right there. Okay, so we can just kind of put some arrows there. And voila, there's the graph. Okay, what are the zeros / roots of this? Negative 1. Negative 1, 0, sure, okay. And where else is it across the x-axis? 3, 0, right? Okay. Okay, we already knew this. It has a minimum, right? We already talked about this, that it's a minimum. Okay? It's concave up, so the vertex is a minimum. I'm just going to circle it, minimum. Okay? Not going to bother writing it, just circle it. Does it have a y-intercept? M-I-N? That works too. Does it have a y-intercept here? Yeah, what is it? Jackson, go ahead.
0, -3.
Beautiful. 0, -3 is right. Okay, right there where it crosses the y-axis. Okay. What's the domain? Negative infinity to positive infinity. You got it. What's the range? Range describes the y values, right? What's the bottom? -4 to top infinity and beyond. Except Buzz Lightyear, I don't know, man. He's not a mathematician because he can't go beyond infinity. That's right. Okay. All right, so there it is. And we already graphed at least 5 points. All right, questions on any of that? Prepare for the test tomorrow. All right, let's turn the page here. All right, I'm going to make this class choice. 1, 2, 3, 4, 5, 6. Which one do you want me to do first?
1, 2, 6, 3, 6, 6,
3, 6,
3,
4, 6, 3, 3.
Six.
All right, I'll do 3 and 6. Let me see if they're the same kind of problem. I might not do, but okay, I see 6. Okay, I see you 6. All right, let's do 3, and I'll talk about 6 as well. Okay, number 3. What format is this in? Is this standard form?
No,
it's not standard form. Is it? Go ahead, Ian. Oh, you got to go. Yeah, go ahead. Sorry.
I'll write the name.
Jackson, yeah. So this is not vertex. This is intercept form. Okay, so the difference there, Jackson, let me write it up here on the board just to show you, okay? Vertex form is this. It's a x minus h quantity squared plus k. So you can see you only have one x minus h and it's being squared. Whereas intercept form is going to be a x minus b x minus q. So you can see it's going to have 2 things there. Okay, so that's 0 and that's vertex. Okay, you're right. They do look kind of similar. Okay, so that being said, what are our zeros? What's p here? What's our zero? What's one of our zeros going to be? -1 from that one. Yep. So p is -1, and what's this 0? +3. Okay, so -1, 0, and 3, 0. You can go ahead and answer that right away. Okay, I can even plot them. -1, 0, and 3, 0. Does it open up or open down? Like, is it open up, concave up, or is it open down, concave down? That's what the open means. Okay? How do we find the vertex? How do we use this P and Q to find our vertex? Where is it going to be? Brady? You raising your hand? Okay. Olivia? You might be able to eyeball it here, right? If that's a 0 and that's a 0, think about symmetry. Okay? What value is in the middle of these two? What x value is between these two? In the exact middle, 1. 1. It's going to be 1. Yeah. Okay, it's the average. Add them up. So the x is going to be -1 plus 3 all over 2. Okay, you add the p and the q together there. So you get 2 over 2, which is just 1. Okay? So here's the x coordinate for my vertex, and then I'll plug the 1 in. So I'll do f of 1, which is going to be 1 plus 1 times 1 minus 3. Okay, 1 plus 1 is 2. 1 minus 3 is -2, so I get -4. So 1, -4 is my vertex. Okay, just like that. So 1, -4. There's the vertex. Okay, I'm going to put that in my table there. I'll go 2 before it. I'll go 2 after it. Now, I already know what happens at -1. It's 0. I already know at 3, it's 0 too. Question, Grayson? Plug. So once you get the x coordinate, you plug it back in. Find the matching y coordinate. Okay. I'll go ahead and plug in 0 here. I'll just do it mentally. Let's see here. It's going to be -3. And then 2, -3 as well. Okay. So 2, -3, 0, -3. Now I got my 5 points. Okay, something like that. Okay. What's the axis of symmetry here? Remember, it goes to the vertex. X equals what? It goes to the vertex, so it's x equals what? What is x equal to for our vertex? What is x equal for the vertex? What value? No, not 3. Look at the vertex. What's the x value? 1, right? It's the x-coordinate, 1. So, axis of symmetry, x equals 1. Okay? What's the domain for any parabola? Infinity, yep. Mm-hmm. What's the range here? Bottom? -4, I think, is the lowest that goes. -4 to infinity. And beyond. Right? Remember. Okay? Mr. Witt, what if I forget that P and Q are like my zeros and that P plus Q divided by 2 gives me my X? What if I forget all that? Calculator. X plus 1, parentheses, right? X minus 3 in parentheses. Graph it. There's all you need right there, okay? Press second trace. Use the minimum because our vertex is at the minimum there. Go to the left, hit enter. Go to the right, hit enter. Go down to the bottom. There's your vertex. Again, a little bit of a rounding error there. It's supposed to be 1 and then -4. And then where's your table? Second graph. There's your table, okay? So again, if you get stuck, use your calculator to help you, okay? All right. Okay, question?
Is that formula, the x equals 3, is that always used when you use intercept?
For intercept form, yes. X is equal to P plus Q over 2.
And then vortex is the -b over 2.
When you're in standard form, it's -b over 2a. Because vertex, think about this, vertex doesn't have b's in it. It's a, x minus h, and k. In vertex form, you have the vertex. It's h and the k, okay? In standard form, where it's ax squared bx plus c, that's where you use the -b over 2a. Here, it's p's and q's, so you use the p plus q over 2. What's vertex form? It looks like, what's that? There is no formula because the vertex form gives you it there, right here. The vertex is 2, -5. That's it, okay? Yeah, back to the problem, you mean? Yep. All right, so we still be number 6?
That's not going to get an F.
You mean still number 6?
No, it's not going to get my quiz.
Why not? Do we still want to do number 6? Yes?
Yes, please.
Number 6? I'll show you here.
Just do like number 1 or 2.
Yeah, number 6 might be good.
Number 6? I think number 6 is a little bit weird. I'm going to do number 6 because what's weird about number 6? Okay, it's got a fraction in front. That's weird. What else is weird about it?
It's a math problem.
So therefore, yeah. So it's missing a term here. What term is it missing? Yeah, Sky. Yeah, it's missing the b. There's no b here. It's no x term, right? If you go back to like normal standard form, like here, number 1, that's more of a traditional standard form we're used to, the ax squared plus bx plus c. But here, there's the ax squared. There's the c. There's no b. So what would b be equal to in this case?
0.
Yes, there isn't one, so it's 0. So a is -1/2, b is 0, c is 3. Okay? So, Grayson, back to what you're asking about here. This is standard form, so we're going to use x equals -b over 2 times a. Okay? Now, -b is going to be -0 over 2 times -1/2. Okay? What's -0? It's just 0, right? What's 2 times -1/2? What's -1/2 times 2? Or 2 times -1/2? What's half of 2? 1. But it's -1/2 times 2. It's going to be -1. But what's 0 divided by -1? 0. Okay? So our vertex has an x-coordinate of 0. Our axis of symmetry is going to be x equals 0. Okay. How can I find the matching y coordinate? What do I do with that x? Plug it in. F of 0. Question?
How did you get 0?
Negative b over 2a.
Oh,
b is 0. Follow me so far?
yeah. That's all I need.
Okay. Okay. We're not going to have set because of the 2-hour dismissal.
It's so late now.
Oh, it is? No way. They did?
Yeah, I just got the text.
Oh, my gosh.
What? Already?
Did they say they're going to reevaluate or no?
Yeah, they said they're going to reevaluate. They
Oh.
said that any other weather-related thing will announce it by 7.
Yeah, FCPS said there's no evaluation. It didn't say no, it's not when they just did it.
Does it say reevaluate at 7 or just says...
It says Friday, March 1st. 2 hour delay replacement early dismissal. That's it.
Okay.
Yeah,
Okay. Well, we'll see.
At the end of the email, they said,
On the email they said...
any other weather-related announcements are needed, we will announce them by 7 tomorrow.
Okay, there you go. Okay, gotcha. Shh. Okay. So there you go. You guys get to sleep in some instead of go home early. Better or worse, who knows? Okay. So anyway, all right, let's finish this up then. So once we have the 0, we're going to plug the 0 in. Now, doing math with 0 is really nice, actually. So we get just 3. And so the y-intercept is 3. So 0, 3 is our vertex. Okay. And again, I'll pick some points, -1, -2. I'll pick 1 and 2 after it. Okay. Type this in my calculator. Make sure you put parentheses around your fractions. Okay, so just like that. Parentheses around the fractions. Up, go to the table. Okay, so I got 0. I got 3. But then I got -1, I got 2.5. Now, you can do that if you like. Okay, but if I go to the very next one, -2, I get 1. I get a nice point. Okay, same thing here. At 1, I get 2.5. But at 2, I get a nice point of 1. So it's kind of your choice there, you know, how you want to do this. Another nice point I see, I get at, let's see here, at 4, I get -5. So I might skip to that one. And if I get -5 at 4, let's see, I get -4 is also -5.
You should do number 4.
Okay, I'm not going to do that many more. I'm going to let you guys start some on your own here, okay?
I don't know under number 4.
I can help you with number 4. Okay. Hang on, Brady. Let me finish up here, okay? All right, so plot these points. There's 0, 3, -2, 1, 2, 1. 1 is 2.5, so 2.5. -1 is positive 2.5 as well, so 2.5. And then 4, -5. And then -4, -5. Okay, and then connect the dots. Okay, something like that. Okay, there's the graph. It opens down. Okay, what kind of transformations happened here? From 0, 0, how did it change? Up 3. What other kind of transformations do we see? What other kind of transformation do we see here? Normally, x squared is like concave up, right? But this is concave down. So what kind of transformation is that? Reflection. And also, isn't this a little bit wider too? Okay, so up 3, reflection, wider. Okay, that's what we'll be good with. Okay, what's the domain here? -infinity to infinity, as usual. What's the range? What's the bottom? Yeah, -infinity. Very good. The bottom is -infinity. Okay. And what is the top? 3. So -infinity to 3. -infinity to 3. Don't forget to include that 3.
What?
All right, and there's your answer. All right, you have the remaining time in class to work on the rest of these. Okay, I'll come around and help as necessary. Drink? Yes, Anna. Question number 3? Okay, I'll be right over. Okay, 1 second. All right. Yes. Homework? Let's see. Good question. No, the only homework is to study, okay, but I want you to work the rest of the time in class on this. Okay, I want you to work the rest of the time in class on this. No, I want you to stay in your seats. Stay in your seats. You guys don't make very good choices when I let you move around, or some of you don't, so I'm sorry to those of you that do. Okay?
I'll start at number 1.
Start at the beginning, that's a very good place to start.